Hello, I'm Seema and welcome to part 7 of the topic Acids and Bases in Organic Chemistry. In this video, I'm going to discuss a few aromatic acids and let us start with it. Let us say we have this pair of compounds and these two pairs that we are comparing. The molecule on this side is cyclohexanol and this is phenol. If we have to compare these two, what's the difference between these two? The point that comes to mind according to the mnemonic carrier is that both of them would have the same charge on deprotonation. If you remove the hydrogens, both of these would have a negative charge on oxygen, right? And the only difference, both of them have the negative charge on oxygen, Ca, so A is also the same. And the third is resonance. That is, the difference that you see here is of resonance. The molecule on the right, that is phenol, has resonance, while cyclohexanol does not have resonance. So how does that affect the acidic strength? So we see that if this hydrogen is removed, the negative charge is borne by oxygen here. So cyclohexanol would have some acidic character. But phenol, on the other hand, in this, once the negative charge comes on oxygen, the electrons, a pair of electrons is available to enter the benzene ring and participate in resonance. Therefore, it would have one of these, this pair would move here, making the negative charge to move here, then the negative charge would move here and here. Therefore, you would have four resonating structures for phenol. And due to resonance, it would render stability to the base, that is the conjugate base, and hence the conjugate base would be stable. Therefore, in comparison to this, phenol would be more acidic. So this is more acidic, right? Now, if we look at these two compounds, this is again, both of them have carboxylic acid, and we have cyclohexane here, but a benzene ring here. So you would have a feeling that you must first judge the resonance, because as we saw in the previous example, it was resonance that was different. But again, let us use the mnemonic carrier. Here, the charge would, on deprotonation, the charge would again be on the oxygen. And as soon as the charge comes on this oxygen, it would resonate. The negative charge would resonate between the two oxygens because this is carboxylic acid group, right? But now the question is that the presence of this benzene ring, how does that affect? Does this negative charge resonate into the benzene ring too? No, it does not, because both the oxygens are so electronegative and they are so stable that the possibility of the electron pair entering the benzene ring here is not possible. Besides, the lone pair of electrons is not on the carbon, it's on the oxygens which are away. So it is carbon which is attached to the benzene ring. So there is no possibility of the lone pair of electrons to enter the benzene ring. Therefore, it is not even resonance. They are basically both the same. The resonance is also the same in both the structures. Then, what is the factor? Does the presence of resonance inside the benzene ring affect the acidity of the molecule in any way? This benzene ring has, as I told you, since it has got conjugate double bonds, the carbons of the benzene ring are sp2 hybridized. And the negative charge, since it shuffles between these three atoms, therefore the presence of resonance in the benzene ring makes the benzene ring more stable and makes it slightly electronegative in comparison to cyclohexane. So if benzene ring is providing more stability to the ion, therefore this one would be a stronger acid, because it would make the conjugate base stabler. Therefore this is the stronger acid, right? Now there is another thing that we must keep in mind when we are looking at the acidity. This is known as the plus M or minus M effect. M stands for the Mesomeric effect. It's again the electron withdrawing or electron donating groups and how they affect the resonance of a benzene ring. Now OH, NH2, Cl and NHCOCH3, these are groups which have a plus M character or a positive mesomeric effect. What is a positive mesomeric effect? any group that has lone pairs of electrons which are available to participate in resonance in the benzene ring, they have a plus M effect. And the presence of such groups affects the acidity or basicity of the compound. Now, as you saw here, that if the lone pair of electrons participates in the benzene ring, it provides more stability and therefore this is more acidic. Phenol is a decent acid. So, phenol is a decent acid because of these electrons participating in resonance, and this effect is known as mesomeric effect. Similarly, a group like NH2, where there's a lone pair of electrons on nitrogen, would also participate in the resonance in the benzene ring, and therefore this also shows a plus M effect. As a result of which, if you deprotonate these atoms, if you remove the hydrogen, the one hydrogen here and a hydrogen here, it is possible to make the compound, the conjugate base becomes stable because of the shuffling of this lone pair of electrons inside the benzene ring. So that also contributes towards the acidic, makes the conjugate base stable and hence makes the molecule acidic. How about the case of chlorine? If you have chlorobenzene, how would you talk of its acidic character? How would you judge its acidic character? Chlorine is highly electronegative in comparison to carbon of the benzene. Therefore, chlorine would show a minus I effect, right? And at the same time, chlorine has these lone pairs of electrons which would participate in, which would show mesomeric effect too, which would participate in the resonance with the benzene ring. So it shows both the effects, the inductive effect, the minus I effect, and the mesomeric effect. But when you see mesomeric effect, in mesomeric effect, the negative charge shuffles between the ortho and the para positions. Because as soon as one of these forms a bond here, the negative charge comes here, then that forms a bond here and this negative charge comes here. So negative charge is actually shuffling between the ortho and the para positions, thereby making the hydrogen of the meta position a little unstable. And therefore, the hydrogen of the meta position is the one that would leave and impart it acidic character. Right? So this is how we judge the presence of a mesomeric group. Any group that shows that is electron donating would show a plus M effect, and any group which is electron withdrawing would show the opposite effect. That is, these are the groups that show the negative effect. So what are they doing? Minus M effect means they pull electrons away from the benzene ring. They have an effect of pulling an electron away from the benzene ring. So if they have an effect of pulling the electron away from the benzene ring, they would also have an impact on the acidic nature or the basic nature of the compounds. We can understand this by taking an example here. Let us say that we have these compounds. Phenol, we have studied, is a decent acid. And we understood why phenol is a decent acid, because of the presence of plus M of the alcoholic group here. Right? So phenol is a decent acid. But what would happen if we add nitrogens to the molecule, to the benzene ring? And how do we do that? We take one example of adding NH2 in the para position. Then we have one compound where we have phenol with NO2 in the para position, and in this compound we have NO2 in the meta position. Right? So let us understand how does this affect the acidic character. If you study here, phenol, whatever, it is a decent acid, I said. So let us take how does the presence of NH2 affect the acidity of this molecule now. Phenol, whatever acidity it had, the NH2 has a lone pair of electrons on the nitrogen. And since it has a lone pair of electrons on nitrogen, NH2 also shows a plus M effect. And if it shows a plus M effect, how is it going to affect the acidity of this hydrogen? How easy would it be for phenol to lose this hydrogen? Let us say that the deprotonation occurs and this hydrogen is lost. The electron, it tried to participate in resonance in the benzene ring, but the presence of this lone pair of electrons, the negative charge, I told you, shuffles between the ortho and para positions. And if you have a pair of electrons at the para position, do you think it's going to allow that electron, more electrons to come to the para position? It would cause repulsion. It would rather push away the electrons. Therefore, the presence of a lone pair at the para position here would lead to instability. Would lead to the instability of the conjugate base, and therefore this compound would be a weaker base. It is weaker acid, I should say, because it will form an unstable conjugate base. This would be a weaker acid than phenol, right? Now let us take a look at NO2. NO2 at the para position and NO2 at the meta position. Well, how would it affect the acidic strength of phenol now with the presence of NO2 on these two positions? If you really look at it, NO2 has the same structure. Nitrogen, unlike the nitrogen of amine, it has this nitrogen of NO2 is positively charged. The reason being that the lone pair of electrons on nitrogen is used to make a bond with this single bond oxygen, right? Nitrogen has formed two bonds with this oxygen, and it has used its lone pair to form a bond with this oxygen and a bond that it forms with the benzene ring, with the carbon of the benzene. So as a result of this, nitrogen is positively charged. Nitrogen of NO2 is positively charged, and the singly bond oxygen is held by coordinate bond. Therefore, it is negatively charged. How does the presence of NO2 group, which is positively charged, would show a minus M effect? It means that instead of pushing electrons or repelling these electrons after deprotonation, the electrons of oxygen which were participating in resonance, instead of rejecting them, the presence of NO2 group at the para position is actually helping, is attracting it. So if it will attract it, it will make the conjugate base more stable. If the conjugate base becomes more stable, it means the presence of the positive charge here is giving stability to the conjugate base. Therefore, this should be a stronger acid than a regular phenol. That is understood. Okay, it's a stronger acid than phenol, but what about these two? If you compare NO2 at the para position and NO2 at the meta position, how would you judge which out of these two is more acidic or less acidic then? So when we look at these two, we find that a nitrogen, the positive charge at the para position, as we already have understood, that OH has a plus M effect and NO2 has a minus M effect. So NO2 is pulling electrons away from the ring while OH is pushing electrons into the ring. But the plus M effect of these electrons, the electrons that come, they do not come to all the carbons of the ring. They come and you find the negative charge at the ortho and the para positions. You find the negative charge at the ortho and the para positions, which means that this NO2 here will help because the electron that comes to the para position will be held strongly by the nitrogen here. So it is helping that structure. But in this case, if you make the resonating structures, you'll find the negative charge shuffling between these three again, the ortho and para. So the presence of this NO2 here, although it may be helping for the negative electrons, the negative charge to be inside the ring, but it does not have a special attraction for the electrons. Another point that I would like you to notice here is that when deprotonation occurs, this hydrogen is lost and a pair of electrons here that moves here to form a double bond. At the same time, this second bond breaks and the negative charge comes here. When that happens, a bond is formed here, and this pi electrons of the second bond, now they move to nitrogen instead of going here. Because this is a possibility. Why can this happen? Because if they move towards nitrogen, the second bond here between nitrogen and oxygen moves back here, and when the pi electrons of the NO double bond are pushed back to oxygen, the negative charge comes on oxygen. So we find that the resonance is not only shuffling between one oxygen and the hydrogens, and the carbons of the ring, but we have one bonus resonance here where the resonance is taking, the negative charge is shuffling between, of course, these 3 points, but also with oxygen. So this structure shows a bonus resonating structure. But this bonus resonating structure is not possible here. In a meta, when NO2 is in the meta position, the negative charge never comes to the meta position. And if it does not, it cannot be pushed into the NO2 group. And the negative charge cannot be pushed onto this oxygen. Therefore, if you compare these two, which are basically having the same groups, only their position is different, we would imagine that since this NO2 group is closer to OH, maybe it has a stronger effect. Rather, it is not proximity which is affecting, it is resonance which is making this group, this compound, more stable. The conjugate base, this one is more stable, so therefore this is more acidic in comparison to this one, right? But of course, the presence of the positive nitrogen, this is stronger, a stronger acid than phenol, but this one is even stronger than this. So if we want to judge the acidic strength of these four compounds, how would we do it? We would say that out of these, phenol of course is acidic. This makes it a weaker acid than phenol, right? So we would say in strength 1, this is the weakest, then comes phenol, then after this is this, or rather let me just put these as numbers and then we'll say which is stronger and which is weaker. Let's say this is 1, this is 2, this is compound 3 and this is compound 4. So 2 is the weakest, right? 2 compound is the weakest acid, then phenol would be stronger. So 2 is weakest, then comes 1, then comes 4 and 3 is the strongest acid. This is the most acidic and this is the least acidic of the compounds. So this is what I had to tell you about the acidic nature of aromatic hydrocarbons too. You would find many questions, practice questions at different places. Try to solve as many questions as you can, and the more problems you solve and the more you think about the different options and what reasons can you give, the better you will get at judging the acidic or basic character of compounds. And as we study organic chemistry topic-wise, we'll do these more in details as we move on. So if the video helped you, please give it a like and subscribe to my channel, recommend it to all your friends and keep returning for more videos in chemistry. Thank you and bye-bye.